Welcome to this video on key concepts in inferential statistics for data mining. Today, we'll discuss sampling distributions, the Central Limit Theorem, hypothesis testing, confidence intervals, and errors in hypothesis testing. Let's dive in. To start, here's an overview of what we'll cover. We'll begin by defining sampling distributions and explaining their purpose. Then, we'll explore the Central Limit Theorem and its implications. After that, we'll outline the steps for conducting hypothesis tests and discuss potential errors in these tests. Finally, we'll wrap up with a discussion on confidence intervals and how to interpret them. Inferential statistics allow us to draw conclusions about a population based on sample data. The two primary methods are testing claims about population parameters and estimating these parameters. For example, we can estimate the population mean moisture content using a sample, enabling informed decisions even when studying only a subset of the population. Sampling distributions describe the possible values of a sample statistic and their likelihood. For instance, the distribution of sample means obtained from repeated random sampling forms a sampling distribution. These distributions are essential for estimating population parameters. In this slide, you see Python code that visualizes a sampling distribution by simulating repeated sampling and plotting the resulting sample means. The Central Limit Theorem states that as the sample size increases, the sampling distribution of the sample mean approaches a normal distribution, regardless of the population's shape. However, certain conditions must be met. Sampling should be random, and the sample size should be sufficiently large. This theorem is a cornerstone of inferential statistics because it applies to both means and proportions. The following slide demonstrates this theorem with Python code, showing how sampling distributions become more normal as the sample size grows. Hypothesis testing is a method for evaluating claims about a population parameter. The process involves 4 key steps. First, state the null and alternative hypotheses. Next, calculate a test statistic from the sample data. Then, determine the p-value and compare it to a predefined significance level. Finally, draw conclusions about the null hypothesis. This slide includes Python code that demonstrates how to conduct a hypothesis test, such as a one-sample t-test. In hypothesis testing, errors can occur. A type 1 error happens when a true null hypothesis is rejected, while a type 2 error occurs when a false null hypothesis is not rejected. The significance level, denoted by alpha, represents the probability of making a type 1 error. For example, choosing alpha equals 0.05 implies a 5% chance of rejecting a true null hypothesis. Confidence intervals estimate the range of plausible values for a population parameter. They consist of a point estimate, derived from the sample, and a margin of error, which accounts for sampling variability and the confidence level. For instance, a 95% confidence interval indicates that 95% of intervals constructed from repeated samples would contain the true population parameter. On this slide, Python code illustrates how to calculate a confidence interval for a sample mean. To summarize, sampling distributions provide insight into population parameters, and the Central Limit Theorem forms the basis for many inferential techniques. Hypothesis tests and confidence intervals enable data-driven conclusions, while awareness of type 1 and type 2 errors is crucial for proper interpretation. Thanks for watching. If you enjoyed this video, Please like, share, and subscribe for more content on data science and technology. See you next time.